Hey guys, welcome to today's lesson. Today we are focusing on rates and direct proportion, primarily rates, but we'll delve into a little bit of direct proportion down the track. Now, first of all, can you remember what a rate is? Well, hopefully if I asked you to come up with a rate, you'll say something like 100 kilometers per hour. You might say 10 meters per second. If we're talking about maybe filling a pool, you might say 10 liters per minute. Okay. Basically, with a rate, we're comparing two different measurements. Okay, often we deal with time and sort of distance, but it's per one unit of that. So you wouldn't be saying, "Oh, how fast you go today?" "Oh, well, I got up to 100 kilometers per 3 hours or per 4 hours." They'd be saying, why per 4 hours? You would say per 1 hour because it makes it easier, right? So a rate is per one unit. So per 1 hour, per 1 second, per 1 minute. And it makes it nice and easy because if we're using 100 kilometers per hour, and I said, well, how far would you travel in 5 hours? You'd simply say, well, 100 times 5 is 500 kilometers. Or I travel 10 meters per second for 3 seconds. That means I traveled 30 meters. If I was doing 10 liters per 1 minute, I did it for 60 minutes. Well, I'm going to be 10 times 60, 600 litres. So per one unit is way easier to use, and that's why we use rates as simplified per one of. Now, the main one that we're looking at today will, of course, be what we refer to as the DST triangle. And I hope that you remember this from science in year 8 or year 7 or even mathematics. Now, this is called the distance, speed, time triangle. That means if I want to find out how far I travel, the distance, we simply need to multiply the speed and the time together. So for example, we said how far would we travel in 5 hours for that first bit? We'd say, okay, I'm doing 100 kilometers per hour. For 5 hours, that gives me 500 kilometers. And it's really easy to work out, okay? If I want to work out how fast I'm traveling, so the speed, well then I'm going to do the distance divided by the time because they're on top of each other. So I'll be doing my speed with my distance over my time. So likewise, if I said, okay, work out the speed if I'm traveling, let's say 500 kilometers in 5 hours, well, you divide them. 500 divided by 5, well, that gives me 100 kilometers per hour, which is what we had there. Okay, and the last one, if I want to find out how long it would take to get somewhere, you would do the distance divided by the speed. So in this instance, you'd say your 500 kilometers divided by your speed. I think we'll see how fast we'll be going. We're going 100 kilometers per hour. So 500 divided by 100 is 5 hours. And again, that's what we had. So you can see the DST triangle works really well, depending on what you are looking for. Now you can remember them one by one, but the DST triangle works out so well. So we'll be doing a lot of distance time, but certainly we'll be using it with graphs and some other kind of capacity style of questions. Now, these are the questions that I'm going to be looking at. I'm just going to fix up those numbers there so that they match up with those particular questions. Oh, that didn't work, did it? Okay. So I'll try one more time if I can get this. All right. Now you might want to have a crack at some of these questions. Again, some of these didn't work out so nice. So I'm just going to try and fix that last one. All right, that's gone okay. All right. Let's have a look at these questions. Now, question 1, you might want to have a crack at these on your own, pause it and come back to me and see how you went. Otherwise, you can just follow on and write these down in your book. Okay, so question 1, write these rates in simplest form. So we want it per one. So we've got 120 kilometers, right, per 3 hours, but I want it for 1 hour. So how do I get it for 1 hour? We divide it by 3. So I'm going to divide the right-hand side by 3, the left-hand side by 3. 120 divided by 3 is 40. We get 40 kilometers per 1 hour, and that's how I write it. Pretty straightforward, right? It's kind of like ratios. Before we were doing ratios like this, 120 to 3, we want it to 1. So we divide both sides by 3, we get 40 to 1. It works exactly the same way. It's why we're doing ratios first. Likewise, 5,000 revolutions in 2.5 minutes. Well, if I want per 1 minute, let's just do 5,000 divided by 2.5. Not that hard, right? Likewise, you can do 5,000 dot dot to 2.5. Okay, put it in your calculator and get it into a per 1. It works out pretty well. But if I do that, let's grab my calculator out. Okay, let's do my 5,000 divided by, I don't really need a calculator for this, but I'm going to be lazy and do it. Okay, we end up getting 2,000. All right, so we get 2,000 there, and it's 2,000 revolutions. Another really quick way you could have done that to make it easy without the calculator, of course, is to maybe make it 10,000 for 5 minutes, and then 10 divided by 5 is 2, and then it gives me 2,000. Would have been a quicker way. That's okay. All right, what about the next question? Question 2. Now, this is more getting into our distance time stuff. So a family took 3 hours to complete the 210 kilometers from their home. Okay, so this is my time and this is my distance, and it wants to find for part A the speed. So D, S, and T. Look at my triangle. So we want to find the speed, which means my distance is 210 divided by my time, which is 3. Well, 21 divided by 3 is 7. Put a 0 on there. It will take me 70 kilometers per 1 hour. Job done. You can see in the DST triangle, it's really quite simple and quite nice to use. Part B says if they increase their average speed up to 90 kilometers, so that's now my speed, how many hours and minutes would the trip have taken? All right, well, my distance is still going to be the 210 kilometers. So now what we're looking for is my time. So looking at the same triangle, time equals distance over speed, right? And so we're going to do my distance is 210, but now my speed is 90. Now, if I do that with my calculator, of course, because this is a slightly harder one to do without a calculator, but 210 divided by 90, now it's going to get me part of the answer, but probably not the whole answer. We get 2.3 recurring hours. Now, that would be fine for hours, but it's specified hours and minutes. Well, what's 1/3 of an hour? Well, 1/3 of an hour is 20 minutes, so I get 2 hours and 20 minutes. You can also press your bubble button. You might remember that bubble button looks like this. Okay, you won't be able to see my calculator at the moment, but if I press mine, it gives me 2 hours and 20 minutes straight away with my answer as well. That works quite nicely with DST. So remember your bubble button or your degrees, minutes, and seconds button will work it out really nice for time. Okay. Now, the next question, question 3, really common question, year 7, 8, and even 9 and 10, which is called that best buy type of question. Which is better value? So we're given that 5 kilos, okay, 5 parts equals $3.80. We got 3 kilos or 3 parts equals $2.20, right? Actually, let's just use the kilos instead of parts. Let's be more mathematical. Okay, so you can see from when I was using those parts, it's kind of like unitary method, right? If I can try and get these both into the same amount of units, then I can compare them. Now, you could compare the dollars or you can compare the kilograms. I'm going to say, in this instance, let's find 1 kilogram of each. So 1 kilogram would equal, well, I'm going to divide both sides by 5. So I'm going to type in $3.80 or 3.8. I'm going to divide that by 5. That's going to give me 1 kilogram equals, I'm going to keep my dollars there, 76 cents. Okay, I'm going to do the same thing on the right hand side. I'm going to divide both sides by 3. So 2.2. I'm going to divide that by 3. We get 0.73 recurring. Okay, I'm just going to put 73 cents there. And so I can see that a kilo cost me 73 cents on the right-hand side, but it cost me 76 cents on the left-hand side. So which is better value? Well, it would be the 3 kilograms for $2.20 in this case, which is not always the case. It's usually the bigger one. The 5 kilograms is going to be better value. But in this case, they try to trick us, and they did it that way. If you wanted to, you could try and find what $1 would buy. And so that case, you're looking for the biggest amount. And so you divide both sides by $2.20, both sides by $3.80. But I find it a little bit easier to look at for the most expensive or the cheapest. It makes a little bit more sense in my head, but both ways will work. Now, question 4, we're nearly there. What are we, 10 minutes? So we've got about 5 more minutes, guys. The amount of fertilizer needed is directly proportional to the area of land being covered. Okay, now depending on your teacher, you might go a little bit further with direct proportion, but I'm going to cut the basics to start with and to see how we go. Now, in this instance, I'm going to look at this question. It says it is directly proportional. What does that mean? It's a little bit tricky. Directly proportional means that basically the two numbers are being multiplied by the same number. So, for example, I'm going to give you a nice little equation. Let's say a cost of a phone call, right? The cost of a phone call, let's say it costs $2 per minute. It's an expensive phone call, right? So $2 per minute. Let's actually say like that, okay? So, for example, if we say it's 1 minute, the cost would be $2. For 2 minutes, the cost would be, well, 2 times 2 is 4. For 3 minutes, the cost will be $6. Okay, and you can see how this is going. They're all being times by the same number. It's being times by 2. A little bit challenging, so I'm only touching upon directly proportional. But let's see how this works in this particular question, because we're going to do a slightly easier method. It says here that a company claims that one 8-kilogram bag, okay, covers 10 square meters. Now, we could use ratios, we could use fractions, lots of different things here. What we basically want to see is how many kilograms would cover 25 square meters. So we know both these are being multiplied by the same number, okay? This just looks like fractions. This just looks like ratios. For example, 8 to 10 equals, let's say, x to 25, okay? Or 8 over 10 equals x over 25. We're just trying to find the missing number. You might not even use either of those and say, hey, I've got to times 10 by 2.5 to make 25. So let's times them both by 2.5. We get 20 kilograms. Okay, and that would be the same method on both of these questions here. You know, you'd say, well, you could do 10 times 2.5 to make 25 times this by 2.5. There's lots of ways you could do it. You could even times this by 10. Okay, actually, no, I wouldn't do that. I could even, on the last one, I could get rid of the divide by 25 by timesing by 25. Same answer. There's so many ways you can do this question. I'm not going to take you through the big formulas, etc. for direct proportion, but it's a bit of mathematics. Use ratios, use fractions, or just use your mathematical head. Don't be too concerned about direct proportion at the moment. Next Unit 10, we delve further into it. This one, though, I want you to take note of. Okay, I've got 2.5 minutes left. Okay, John went for a long day ride, and this graph here is a distance time graph, and it's going to explain what John was doing. Let's say, for example, that John starts at home, okay, and he's going to go on this little trip. He's got his bike ride, and in the first 5 hours, you can see that John has ridden how far? He's gone up 10 kilometers, okay? What does this horizontal line mean here? Well, it means that there is no more distance happening, which means from 10, let's just move this a little bit onto the line so it makes it a little bit easier. Okay. And I'm going to move it down. That's a bit easier to read, isn't it? From 10 o'clock to 11, 12 to 1 p.m., what's happening? He's not going anywhere, so he's had a bit of a break for a few hours. He's ridden 10 kilometers, he's pretty tired, and he's going to have a bit of a break. Then he rides a little bit further, and then what happens then? Well, he turns the direction and starts to ride back home. So we're starting to draw a little picture about what John's doing. So the first question says, how far did John ride in total? Well, he rides 10 kilometers from 5 to 10. He doesn't ride anywhere from 10 to 1. He then goes, well, it's going 2, 4, 6, 8, 10. It's going up by 2, isn't it? So 2, 4, that's 14 kilometers. So he does another 4 kilometers here. And then he's 14 kilometers and rides all the way home. That's another 14 kilometers. So we've got that first question there. We've got 10 plus 4 plus 14, which equals 28 kilometers in total. And that's my part A. Now, likewise, you could have just figured out he rode 14 up and rode 14 back. That's 28 kilometers done. Not a bad question. When did he have a break? We had a break between 10, 11, 12, 1 p.m. So you're going to say 10 a.m. to 1 p.m. It might say for how long did he have it? 10 to 11, 11 to 12, 12 to 1, 3 hours. Nice and easy. And you can see that's 3 hours across there anyway. Now, the last question, which is usually the most challenging, says, what speed did John return home between 2 to 3 p.m.? We can see at 2 p.m., he has legged it home. So he might be going all the way down a hill, who knows? But he's legged it home. And let's use our DST triangle. Okay, speed equals distance divided by time. Okay, remember our DST. Whoops. Yep. So speed equals distance over time. So my distance, well, that's 14 kilometers away, right? And he does that in a 1 hour period, which means his speed equals 14 kilometers per hour. Now, the other way you could look at that, for those a little bit more remembering about linear relationships, you could also, that's the gradient, okay? The rise over the run, the 14 kilometers over the 1 kilometer, which means he's going 14 kilometers per hour, okay? He's going, well, it's kind of like downward, so it might be negative, but we don't have negative speed, okay? But he's traveling 14 kilometers per hour on the way home. I could have asked what was his first speed between 5 and 10. Well, that's 10 kilometers over 5 hours, so that's 2 kilometers per hour. Look at the big difference of time that he's spent. He's gone 2 kilometers per hour versus 14 kilometers per hour. So he had a real nice, easy break to start off with and then smashed it home. Okay, look, guys, I know it's a little bit wishy-washy here sometimes with rates, and it's quite wordy questions. They're those working mathematical questions. Have a crack in your book about this because there are lots of good questions there. Any questions, of course, always email me via Canvas, and hopefully we'll see you soon. Have a wonderful day, gents.